Welcome to this new activity, which is about logarithmic and exponential equations. So here we have to find x in each equation, but to start with the first one, let me make a quick reminder on this property. If you have, guys, log b, a basis b of x equals y, then x is equal to b to the power of y, okay? So in this case, the basis is 3. So we're going to apply the property and we'll get x equals the basis 3 to the power of y, which is 2, and it's equal to 9. And here we know that we have to check that the argument of the log is positive and x equals 9 is positive. So we found x. Let's move to the second one. Here we have 4 to the power of x equals 8. And to get x here, we have to apply a logarithm. When you have the unknown in the power, don't hesitate to apply a logarithm function to get x. And here we'll use a property which says that any logarithmic function, okay, of x to the power of p equals p log b of x. So let's apply this on this equation. And especially here, I will use the natural logarithm. So I will apply the ln on both sides. Ln of 4 to the power of x equals ln of 8. Okay? Then I will use this property, the power property for logarithmic functions. Okay? So I will get x ln of 4 equals ln of 8. And to get x, you just divide by ln of 4. So x is equal to ln of 8 over ln of 4. Of course, you can simplify this expression or you just keep it like this, okay? So you found your x, okay? If we move to the third one, we have here a bigger expression or equation. We have log b of x equals 3 log b of 2 plus half log b of 25 minus log b of 20. So before starting solving this equation, we're gonna make a reminder on some properties of log functions. So first of all, you have to know that log, and when I say log here, any logarithmic function including ln or the decimal logarithm, okay? Log of a times b, any quantity a times any quantity b, is equal to log of a plus log of b. Second property, log of a over b equals log a minus log b. And the third property, which was used in the previous example, is log of any quantity x to any power p equals p log of x, okay? Now, let's try to solve this. So here the idea is to write the right-hand side here as a single logarithm expression. It means we're gonna try to write this log b of x equals log b of something, okay, of an expression. So let's try to manage this right-hand side here term to get a single logarithm, okay? So let's write that 3 log b of 2 plus half log b of 25 minus log b of 20 equals what? By applying the third property here, we can write that it's equal to log b of 2 to the power of 3. So here we used the third property to transform this first term, okay? So what's in yellow here is transformed to this expression, okay? Now, for the second one, we have plus half log b of 25. Again, we're going to apply the power rule, this third rule here, and we'll get plus log b of 25 to the power of half, and we'll keep the last term since we can't modify it for the moment, log b of 20. Then it's equal. Now log b of 2 to the power of 3, which is log b of 8, plus log b of 25 to the power of half. But 25 to the power of half is the square root of 25, which is 5. Remember that x to the power of half is just square root of x. Okay? So plus log b of square root of 25, and the square root of 25 is 5. Then minus log b of 20. Okay? Now, we're going to apply first the sum rule. It means this one, log a plus log b is equal to log a times b, to these first two terms. So we're going to get equals log b of 8 times 5, and 8 times 5 is 40, minus log b of 20. Now, if you apply the second rule here, log a minus log b equals log a over b, you're going to get equals log b of 40 over 20. And 40 over 20 is equal to 2. So this right-hand side term here is equal to log b of 2. So what is x in your opinion? X will be equal to 2. Since this right-hand side is equal to log b of x, so we can determine by identifying the argument of log b here. We have the same basis, same function, so the same argument, since the logarithm function is a one-to-one function. So we're going to get x equals 2. This is the solution of our equation. Now we're going to move to the next one. Log b of x plus log b of x minus 4 equals log b of 21. Here, before starting our solution, we're gonna determine the domain of this equation. Since we have an argument which is not x but x minus 4 here, we have to pay attention to these details. Okay, you know that any argument of a logarithm function must be greater than 0. So first, we have an argument here, which is x, so we have to check that x is greater than 0, and x minus 4 also greater than 0, which makes x greater than 0, and this is an AND condition, because the two conditions must be respected here, satisfied, so x minus 4 greater than 0, so x greater than 4. So your x must be greater than 0 and greater than 4. So the combination of the two conditions gives x greater than 4, because the second condition is harder than the first one. So here you have to check that your x is greater than 4 when solving this equation. So keep this in mind. Okay. Now we're going to start solving our equation. Again, here we're going to use the logarithm property. We have log b of x plus log b of x minus 4. It's a sum. So it's when you have sum of two logarithms, it gives the logarithm of the product. Okay, so here we can write our equation as log b of x times x minus 4 by using the first property in the previous page. Okay, so x times x minus 4 equals log b of 21. Again, here by identifying the arguments of the same function log b on the two sides, we can conclude that x times x minus 4 equals 21, which gives x squared minus 4x equals 21. And we have a second degree equation, x squared minus 4x plus minus 21, equals 0. And by solving this equation, you will get x equals -3 or x equals 7. So these are the two solutions of the second degree equation. But the question, are they solutions of our equation? We have to check this, guys. we have to check that our x is greater than 4. And which solution is greater than 4 here? It's the x equals 7. The x equals -3 must be excluded from your set of solutions, okay? So this is excluded, okay? So you keep only the x equals 7 because it's the only one which is greater than 4. So your solution is x equals 7. Next one. So log 10 of x minus 1 minus log 10 of x plus 1 equals 1. Here, we'll use the difference property. Log a minus log b is equal to log a over b. So we're going to apply this. But first of all, let's determine the domain of our equation. We have to check that our x minus 1, the argument of the first logarithm here, is greater than 0, which makes x greater than 1. So this is the first condition. And the second condition is x plus 1 greater than 0, which makes x greater than -1. So here we have two conditions, and we're going to check the intersection of these two conditions. Okay, let's place the two values, -1 and 1, on a real numbers line, okay, just to check what is your domain, okay? So negative infinity here, infinity, -1 and 1. So the first condition is x greater than 1. X greater than 1, it means all these numbers in red, okay? And x greater than -1, which means x greater than -1, which means this interval. Now, it's easy to check that your intersection is this interval. So the first condition is harder than the second one, and the intersection gives the domain, the open interval, 1, infinity. So x must be greater than 1. This is your condition. Now let's start solving our equation. We said that log 10 of x minus 1 minus log 10 of x plus 1 is equal to log 10 of x minus 1 over x plus 1. Okay, so log 10 of x minus 1 over x plus 1 equals 1. Now, by applying the exponential function with basis 10, we're going to get x minus 1 over x plus 1. Remember the first example, we said that if you have log b of x equals y, then x is equal to b to the power of y. The basis here is 10, so we just apply this rule and we'll get 10 to the power of 1. So x minus 1 over x plus 1 equals 10 to the power of 1, which is 10. So let's solve this. X minus 1 over x plus 1 equals 10. It means x minus 1 equals 10 times x plus 1. Then we expand here, we regroup the similar terms. So x minus 1 equals 10x plus 10. Okay. We move the 10x to the left. We'll get x minus 10x, which is negative 9x, and the negative 1 to the right-hand side. So we'll get 10 plus 1, which is 11. So here we'll get negative 9x equals 11, which gives x equals negative 11 over 9. So x equals negative 11 over 9. This is the solution of our equation, but remember that we have to check that x is greater than 1. Is the negative 11 over 9 greater than 1? No, the answer is no, it's not greater than 1. So this is not a solution for our equation, and you have no solution for your logarithmic equation. Okay, so let's repeat. First of all, determine your domain, set a condition on x by checking the argument of the logarithm, then try to solve your logarithmic equation using the logarithmic properties, okay? Log of a plus log of b is equal to log a times b. Log of a minus log b is equal to log a over b. And log of x to the power of p is equal to p log of x. So use all these properties to solve your logarithmic function, logarithmic equation, sorry. And then when you find the solution of your equation, check your initial condition on the domain of logarithmic functions, okay? Thank you for your attention and see you in the next videos.